In this problem, we're asked to approximate all angles of theta in the interval 0 to 2 pi, where theta is in radians that satisfy the equations. The first equation is we want to take sine of theta. It would give us the same result as the ratio of 0.4195. In order to investigate, we will look at how we would find theta. We would know that the sine of theta is equal to k, where k can only take on the values of -1 to +1. In this range, we can find theta in radians, as theta is the sine inverse of k. We will recognize that on the unit circle, sine of theta produces positive values between 0 and 1 in quadrants 1 and 2. Sine theta produces values between -1 and 0 in quadrants 3 and 4. Therefore, if k is positive but less than 1, our calculator is going to give us a quadrant 1 angle as our value for theta. If k is between -1 and 0, our calculator will give us a quadrant 4 angle for theta, or it will produce that negative angle rotated in the counter or clockwise direction. Therefore, our values of theta that are going to be produced by our calculator are going to be between -pi/2 and pi/2. We will have to do a little bit more work in order to find the two angles that produce a positive value lying in quadrant 1 and quadrant 2. If we took our calculator and looked at the sine inverse of 0.4195, we would get a result of 0.43 radians, or an approximate result, rounding to the nearest 1/100th of a radian. That would give us our quadrant 1 angle that approximates 0.4195 when we take the sine of it. We are now asked to find our quadrant 2 angle. That quadrant 2 angle, starting in standard position and rotating counterclockwise, must have the same reference angle as our quadrant 1. We will recognize that in order to get to the negative x-axis, we would have to go pi radians. Therefore, our second value of theta can be given by pi minus 0.43, or approximately 2.71 radians. In order to do this same thing for cosine and tangent, we will have to recognize what our calculators will give us as values for theta. So we would know that the cosine of theta is equal to k. Again, k can only take on the values between -1 and 1, such that theta is equal to the cosine inverse of k. We will recognize on the unit circle that cosine is positive in quadrant 1 and quadrant 4. Cosine is negative in quadrants 2 and 3. Therefore, when we type in a positive value for k, we are going to get a quadrant 2 angle. If we couldn't get that same value for typing in a positive k to give us our quadrant 4. Therefore, we'd have to type in a negative k, and it would produce our quadrant 2 angle. In order to do this, let's type in the cosine inverse of -0.1207. Typing in cosine inverse of -0.1207 gives us our quadrant 2 angle that has radians of 1.69. In order to find that quadrant 3 angle that also has the same cosine value, we would have to find that reference angle. That reference angle is given by pi minus 1.69, which is 1.45. So our second value